Hello, this is your teacher, and I am creating my own video tutorial that discusses how to convert numbers in our base 10 system to other base systems. Particularly, I want you to understand how to convert numbers in the base 10 system to the binary system, which is a very common and modern used system, and the octal system, which the introduction video of this section talked about a little bit. If you think about the cartoon world that the YU professor was speaking about, so we're just going to practice with those two. You may download the worksheet that accompanies this video. It should be attached right to, or just right above the video, or right below the video in your Schoology section. If you don't have a printer, you're welcome to annotate on top of this. You can just download the link and annotate on top of it. Or if you really want to and you don't want to print it off, you could just as easily create your own little grid that shows you how that allows you to follow along and practice. Either way, what I'd like for you to do now is just pause the video and make sure you've got a pencil and paper in front of you so that as we go through these examples, you can write along with me. So you're going to have to take your own individual notes. You won't be turning these notes in, but they will be helpful for you in your end of section quiz that you'll be taking. And also you'll want to use them and refer to them when you're creating your own video demonstrating how you convert your favorite number to octal and binary. So let's just dive right in here and let's just take a look at this. I want you to note that in our base 10 system there are only 10 digits that represent all of the possible values we could ever come up with. Those 10 digits are 0 through 9. A lot of people, a lot of young students get confused and think the 10 digits, oh, there's 1 through 10, but that's not entirely true, right? 0 is the first digit. I know we usually start counting when we say 1, 2, 3, 4, 5, not 0, 1, 2, 3, 4, 5, but 0 is its first digit, and 0 is an important value. It's a placeholder for locations of numbers when they're not when we don't have anything. It's important to be able to demonstrate an absence of something just as much as it's important to demonstrate a presence of something, some quantity. So these are your 10 digits in our decimal system. We call it the decimal system, or base 10. So many people don't really think about how our base 10 system works, but if you're working with a number of objects, let me just create 1, 2, 3, 4, 5, 6 items here. Then what we could do here is think, okay, I've got different columns, different place values that represent different quantities or different groupings of things. In every system that you're going to be working with, at least in this class, you're always going to have a column or a grouping of 1. Groups of ones. How many of one item do you have? In our base 10 system, we can have groups of ones from anywhere from 0 to 9. But of course, as you know, once we get to groups of something larger than 9, then those go away, and we take those groups and push them to the next level, groups of 10s. Then we continue grouping groups of 10s together until we get to the groups of 100s. And I believe at this level, if you're a 7th grader, you already know this information. It's very important that you understand this. But maybe you haven't really thought of it this way before. And so that's what we're going to do today. Again, I was just going to make up something. Let's just go. Let's say we had 6 items. 1, 2, 3, 4, 5, 6. Let's say I'm counting 6 rocks. Well, in our system, that means that there are 6 ones. There are 6 of them. Let's come up with something different. I'll just do something a little bit bigger. Let's say I have, I don't know, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of something. Okay? Well, as we count this, we've got, okay, well, how many groups of 10 do I have in here? because I've got more than 10 groups of 1s. Like I've got more than 10 groups of 1s. So how many groups of 10s? Let's go out here first. And I say, well, like I've got 4, 8, right here. I've got 10 group. I've got one group of 10. I've got a group of 10 right here. And then I've got I'll do a different color here. 1, 2, 3 other items. 3 other items that are still in a group of 1 that aren't enough to be in a group of 10. So this is how our number system works. It's tedious to think of it this way. We don't think of it this way anymore, but there was a point where we were learning this, and this is how we thought of it. This is how we worked through it. Okay? So this is important to understand. Let's move on to the next slide. So in binary system, you have two. Sorry, I'm spacing the names. You have two symbols that represent values or quantities or groups. You've got 0 and 1. That's it. A lot of people get confused and say, okay, this is a base 2. If this is a base 2, where is the 2? I should expect to have 0, 1, and 2. But that's not true. This would be a base 3 system, and I know that that's going to sound confusing to a lot of you, but that is those are the only two symbols that can represent the quantities that we have. If it's a base 2 system, that means that there are two symbols here. So, like any other base system, 0 is an important quantity. It's the absence of nothing. If I have 0 groups of any group, then that will be important to show that. And so 0 in the base 2 system just comes out to be 0. 1 in the base 2 system, the binary system I'll just call it, still comes out just to be 2. So far there's nothing different. But now watch what happens once we get to this group. Let me direct your attention down here. Okay. So as you're looking at this, I can go up to 1 item in a group of 1. But once I get 2 items, 2 of something, let's say I've got 2 sticks, that is going to be regrouped and it's going to be brought over here into one group of 2. So that'll go away. So in other words, if I have 2 of something, let's go here, that is actually going to be written as 1 group of 2 and 0 groups of 1. Or in other words, 1 group of 2 and 0 groups of 1. So the number 1, 0 represents 2 in the base 10 system. So 1, 0. And by the way, I will say this. When we're denoting other systems, other base systems, we can usually say, so like this would be 10 subscript 2. So that little 2 down there is just saying, by the way, we're working in base 2. So this whole page is going to be base 2, so I'm not going to write that every time, but you understand that a 10 base 2 equals 2 base 10. And so let's keep going with this. Don't panic too much if you're feeling a little overwhelmed. I think just seeing it over and over, practicing a few times is going to be exactly what you need. Okay, so let's just keep going with this for just a second more. Let's keep going. Let's go base 3. Oh, sorry, 3. I'm sorry, 3 in the base 10 system. Okay, 3 in the base 10 system. 3 is representing a group of 2, 1 group of 2, and a group of 1. There are 3 items here. And we'll just do this. There are 3 items. As soon as I get a grouping of 2 here, that grouping of 2 must be brought over and is demonstrated here. So that grouping of 2 goes away. But I'm still left with this additional group of 1, which can go right here. So 3 base 10 is the same as 11 base 2, or 1, 1. Do a few more just to kind of show you this pattern. And feel free to pause and go back at any time in this video. So 4, if I've got groups of 4, so like 4 items, 1, 2, 3, 4. Well, okay. We've got a group of 2 and a group of 2. So that becomes, so I've got a group, like another group, 1, 2, and another group, 1, 2. But remember, whenever I have a group of something that is in 2s, that is automatically going to be grouped into the next column. So I couldn't write 2, 0 and call that base 2 system. I couldn't do that because this symbol doesn't exist in the base 2. I can't write that. So as soon as I form another group, that becomes a group of 2 in this column here. Those go away, and I'm left with 1, 0, 0. So 1, 0, 0 is the same as 4 base 10. Okay. So I've got one group of 4. Now, this is where things either are getting really tricky for you or they're starting to click, I think. Let's do a group of 5. So 5 items. 5 items. I'm going to have one group of 4. There are 5 things, so those 5 things can get grouped into groups of 2, so those 2 would come over. But once I have those 2 things, those things would come over, and that becomes 1. So I've got 5 groups of things here, and so, I'm sorry, 5 things, and so I can put them into one group of 4, one group of 4. There are no groups of 2 at this point, but then there is a single 1 left over. So 101 represents the base 5. I should do a few more examples, but I think there's a few more things I want to look at, so let's move on. So what we're going to do then is we're going to pick a random number, and we'll just do 3 examples, just maybe a slightly larger number, hopefully nothing too big. And this is where you get to follow along and copy this down, work along with me. So here's what I would recommend. I'm going to make up a number, and then I'd like for you to pause it, try to see if you can find the correct number, and then unpause it and watch me solve it and listen to me solve it and convert it. If you converted it the same way as me, then give yourself a high five or go find somebody and tell them what you have accomplished, because that is tremendous. And if you haven't, watch through it and follow along with me and fix your mistakes, and then we'll move on to the next example. So let's do something a little bit bigger. Let's do 16 in the base. 16 in the base 10 system. So I want you to write down 16 subscript 10, and I want to figure out what that would be equal to in the base 2 system, in the binary system. Okay. So there were some things that I was hoping that you would see, and I didn't actually draw attention to, so I will do so now. Each placeholder, each place value, increases by an exponent of 2. So, for example, this first group here, it would be 2 to the power of 0. As a quick review, anything to the power of 0 always equals 1. And I don't have time to explain why that is in this video, but there's other things out there that explain that, so you're welcome to go explore that. This column is all of the 2 group to the power of 1. So I've got groupings of 2's here. This would be 2 to the power of 2, groupings of 4, 2 to the power of 3, groupings of 8, 2 to the power of 4, groupings of 16s, 2 to the power of 5, groupings of 32, 2 to the power of 6, groupings of 64, and I'll bet you could figure out what this next column would be, and the next, and the next. So even very small numbers can get quite large in the base 2 system because I only have 2 symbols. So let's look at 16. I think this one's actually going to be quite easy for you. You might want to pause it now and just take a look, see if you can convert 16 items in the base 10 system into the binary system base 2. Hopefully you were able to solve this, and now it's my turn to go ahead and show you how I do this. So as I look at this, I think, okay, I've got 16 items. Okay, I've got 16 things, and those 16 things can be grouped into a single group of 16. One single group of 16. After that, there's going to be nothing left over. So there's going to be no 8 left over, no groups of 4s left over, no groups of 2s left over, and no groups of 1s. So in other words, this number 1 0 0 0 0, so 1 and 4 zeros, 1 0 0 0 0, subscript 2 is the same as 16 base 10. Okay, so hopefully you're able to get that. Let's do another one that doesn't come out to be quite so even. Let's do 17. Let's just do the next one up. 17 base 10. And we want to convert that to the base 2 system. Okay, so this would be a good time for you to pause it and try it on your own, and then let's come back and work through it. Okay, so with this one, I've got 17 items, and I know that 16 of those items can be grouped into a group of 16. So that'd be one group of 16. Now at this point, there's going to be, that's 16 of the items, there's going to be one thing left over. And so that one thing is going to be grouped into this grouping of 1. There are no groups of 2s, there are no groups of 4s, and there are no groups of 8s. So the number 10,001, whoops, 10,001, and I really shouldn't say it that way, I should just say 10001, subscript 2, or in other words base 2, is the same as 17. Alright, let's do one more in the base 2 system, and hopefully by now you have it. And I think you realize that the larger numbers can be a little bit more difficult, but you know, let's just think about it. Let's do something. I don't know. Let's go crazy here, and let's say let's go to like 72. Okay. I'm not sure how this is going to work out, but 72 in the base 10 system, what does this look like in the binary system? Okay, so the first thing I need you to understand is that there's a one single group of 64. That's going to be nice, okay? One single group of 64, so I know that's there for sure. After that, I've got 72, take away 64, leaves me with 8. Leaves me with 8. And that's actually quite nice. That group of 8 can be placed right there, that last group of 8. So, one group of 64, no groups of 32, no groups of 16, one group of 8, no groups of 4s, no groups of 2s, and no other groups of 1s. So here we go. 1 0 0, 1 0 0 0. I just ran out of room, but that's okay. Base 2 is the same as 72 base 10. Okay. Hopefully by now you've seen the patterns, and I will bet you that in the next video, the next practice video that shows the other half of the worksheet, I'll bet you that the octal system is going to be easier for you. Okay, so we're going to stop the video at this point and move on to the next one.